So now we will be talking about diffraction of light when light passes through a single slit. So consider this is a kind of a slit. You can see that the light is coming from this direction, and the light is blocked by this one. And this side, the light passes through this single slit. When the light passes through single slit, it hits the screen. So it hit the screen on different places. And one of those places is P. So what we see from this single slit, what is happening? The wave which is coming is basically divided in different wavefronts, although it is going through a single slit, like this wavefront and this wavefront and this one and this one. And when all these waves they reach to the screen, what we see dark and bright, and we see a diffraction pattern from this single slit, which exactly is looking like this. So if you see here in this diagram, what we see in this diagram, that we have central maxima, we have the light when it is coming, so there is a bright with high intensity. Then this goes here, this is totally dark, and then you see that the intensity increases and then it decreases, and again this is bright and this is dark. But what we see here, that if you see this one, this is very bright, this is kind of lesser bright than this is lesser than this, and this is the least one. So what is happening, the diffraction at the central point is maximum, at the central maxima is maximum, but if we go away from the central maxima, the brightness decreases. So this is a pattern from a single slit diffraction. But like the misconception here in Pakistan, what we have studied and what we have seen, one thing more I want to explain here, that this is the equation which is governing your diffraction pattern. So if you see here in this equation, you see that the intensity is directly related to your maximum intensity. And the second thing is it's also related to the sine alpha, but sine alpha is sinusoidal. So because of this sine wave, what we see bright and dark. But because of this alpha, as you see that this is square, so it never goes to the negative side. It is always positive. The intensity is always positive. But what we see, like if we see here, this one is always increasing. So this one is repeating by itself. But this one is not repeating itself, but this is gradually increasing. And with this increase, what we see, that initially at the central maxima, what we see at the central maxima, sine alpha divided by alpha, when alpha reaches to 0, is equal to 1, and the intensity is equal to I maximum. But when we reaches to like alpha increases, for example, alpha is pi by 2, so this is 1. This is pi by 2 square, pi square divided by 2 square. So we see that what happened, this is again 1, but divided by like a number. Now if we go to the next one, the next maxima, that will be 3 pi by 2, 3 pi by 2. So this is again, we will be getting 1 for this, but the denominator is further increased. And that's why we see that as per this equation, if we come back to our diagram, what we saw, that because of this equation, the intensity, you see that because of that equation, the intensity is increasing. Look at here, then look at here, and if you go further, so the intensity is decreasing step by step. One thing more I want to clarify here, which is very important, that usually we have in mind that when a sine theta is equal to m lambda, this is in our mind. We generally consider this is criteria for what? For maxima, for bright fringe. But in single slit diffraction, this is not the case. If you look here, so a sine theta is equal to m lambda, this gives us minima. This gives us dark when m is equal to 1, 2, and 3, and so on. So when m is equal to 1, that will give us what? That will give us first minima. When m is equal to 2, that will give us second minima. And when m is equal to 3, this is my first minima, this is my second minima, and this is my third minima, and so on. So this was something which is also kind of important to understand about the diffraction when we talk about a single slit diffraction phenomena. Now, the general misconception is this, that we say that when the wavelength is comparable to the wavelength, then diffraction happens. Look at here. These are different cases. Here the diffraction, look at here, the wavelength is comparable to the wavelength, to the slit of the size. In this one, the wavelength, like 5 times of the wavelength is the slit size. So the slit size is 5 times of the wavelength. Look at here, the slit size, that is 10 times of the wavelength. So our misconception we had, we were considering, and we were, like when we studied that diffraction happens when the wavelength is the comparable to the slit size, like here. So here the slit size is comparable to the wavelength. So in this case, if you see that the wavelength is comparable to the slit size, diffraction happens. We have intensity all over on the screen. But if we go and we increase the slit size, by increasing the slit size to 5 times, what we saw here, again we saw diffraction happens. So again diffraction is happening, and we have a beautiful diffraction pattern. If we further increase the slit size, like here, what we saw in this one, this is a beautiful kind of, a figure where the slit size, it is 10 times of the wavelength, and we see the diffraction pattern is sharp. The diffraction pattern is beautiful. So this means that the diffraction pattern is sharp when the slit size is 10 times of the wavelength. Now the question is this, that if the slit size is further increased to 20 times of the wavelength, naturally again we will be getting a diffraction pattern again. We will be getting a diffraction pattern again, but that will be not as beautiful as this one. So now this misconception we had in mind, that diffraction happens when the slit size is comparable to the wavelength, that was totally wrong. So the diffraction, basically the spreading of light. The spreading of light has nothing to do with the slit size. If you increase the slit size or you decrease the slit size, in each case what will happen, the light will be spreading out. The light will be spreading out, and this phenomena of the spreading out is called diffraction of light. So this misconception which we have because of the textbooks we use here in Pakistan, because most of the textbook they say that diffraction happens when the slit size is comparable to the wavelength. I hope that now this is supposed to be clear for all of you. If we go further, and let's suppose we have 2 slits, and let's suppose 2 slits, for example, in the first here you see, in this one, in the first we have the slit size for each case is comparable to the wavelength. The slit size for each has comparable to the wavelength. So in that case, what we see, we have two slits, and when the light passes through both of those slits, that will give us a diffraction, basically a pattern like this. And generally, this is called interference. This is called interference. Now, this is coming from two slits, and both the slits are comparable to the wavelength. Both the slits are comparable to the wavelength, and that's why we see only the interference pattern, because the intensity of each bright is the same. The intensity of each bright is not changing. Now, what happens if we increase the slit size? For example, the slit size of 1 is changed, the slit size of 1 is increased. So when the slit size is increased and the slit size of the other is also increased, then from each slit we will be getting a diffraction like this. This is a single slit diffraction. So single slit diffraction from 1, then single slit diffraction from the other, that will be also a kind of the same, but little, position will be little bit different than this one. So one will be to the left and the other one will be to the right. Otherwise, the patterns of both of them will be the same. Now, if we open both the slits together, so by opening both the slits together, what we are getting something like this. Now look at this pattern. Look, this one. This one shows what? This one shows diffraction pattern. But along with diffraction pattern, we also see that we have interference. We have interference. So within the diffraction, we see that the diffraction pattern in this case is superimposed by what? By interference. Now this happens, this kind of, plot or this kind of intensity or this kind of light, because each of these shows light. So these are lights maximum light, smaller, and when we reach here, the light is 0. But even here within this diffraction pattern, what we see here, all these points, what we see dark. We see dark. So, here what we see, a very beautiful pattern where diffraction pattern is superimposed by what? By interference. So this is the concept. This is the basic concept. And this is very important for the understanding of optics, because optics, this is the beginning to know what is diffraction, what is interference, and what is polarization. If we don't know diffraction, if we don't know interference, if we don't know polarization, then, we need to understand them, because these are foundations of these are the foundations of physics. The foundations of physics. So with these words, I think now we will be going back to our basic topic, and we will be discussing our original topic, which is kind of important to do. So in the next topic, we will be discussing our double slit diffraction kind of experiment.